Now we're ready to jump over here. So we've gone through all of these terms. We talked about intercept form, talking about turning points, tangency here, our global and absolute max and mins, lots of these things right through here. All very important stuff. You can go through and read all that for detail if you want to. Just kind of pause it and read through that if you want to look at the details of that. But that sets us up for this little chart to kind of walk through here. So as we're going to look at these characteristics of a cubic even closer. Okay, so the first thing here, we see that we got three different functions. All three are cubics. All three are cubics. Okay, so if I multiply, so this is x to the third. If I multiply these two, that would give me x to the third. Well, if I multiply this stuff out, I don't know what the rest of it would be, but I know that I would get an x to the third eventually. So I can look at these guys, and by the way, this here, this is intercept form. This is intercept form as well. Okay, you say it looks like it's factored to me. Well, it's the same thing. Remember, they're the same thing. Okay, so here we go, and it says first thing it says distinct factors. Well, looks like there's one distinct factor 3 times for that one. This one's got 2. We got 3 here. 1, 2, 3 distinct factors. Okay. Okay. This has got 1 distinct 3 times, right? And this has got 2 distinct, but one of them is repeated. Okay. Now it says, what are the graph's x-intercepts? Well, another word for x-intercepts are the zeros. So what's that mean? What numbers can I plug in for x to make it equal to 0? So what can I plug in for this first function to make it equal to 0? 0. Okay. What about these guys? Well, I could plug a 0 in for x squared. That'd make it 0. But what could I do here for this x minus 2? Well, if I put x minus 2 equal to 0 and I added 2 to both sides, I would get x equals 2. Yeah, 2 minus 2 is 0. Okay, so that would give me 2 zeros. And the same thing for our last ones. So 0, 0, or 2 would make it 0, 0, 2, or negative 2 would make that 0, because the x-intercepts are also known as the zeros of the function. Okay, now you kind of see where it's called the intercept form, because you can easily look at this guy right here and figure out what the x-intercepts are very easily. That's why it's called the intercept form. Okay, now let's look at this next group here. It says, is the graph tangent to the axis? That means, does it touch the axis, or does it cross the axis? Well, this is just the parent function at x cubed, right? So it's going to cross the x-axis, but does it just cross it straight through? No, it does a much fancier way than that, right? And so I'm going to add something to this dude. I'm going to actually say, hey, not only does it cross right there, it swerves. Swerve. It's going to swerve as it crosses. All right, that's the parent function. Okay, now this guy at 0, it's got that square. And what did we say about the squares? That gets a bounce. So it says tangent, but I'm going to say bounce. Right? And then this guy here, that's to the first power. That's going to be just straight crossing through. And then all of these, okay, so go back to this idea that I showed you on the previous page. We looked at this, okay? When we go to look at these graphs, we're looking at it's either going to go straight through, it's going to bounce, or swerve. And again, bounce, which is the same as that. Those are our choices. And so depending on what kind of exponent we have, that's how we know what's going to happen. So these are all to the first power, so they're going to go straight through. Straight through. That one's going to bounce, and this one swerves. And so you see where these words are coming from. Okay, so let's jump on down here. Turning points. Okay, we talked about that previously. This one doesn't have any. This guy has 2. This one has 2. I guess now would be a good time to kind of show you what those things look like. So here's my graphing calculator. I got just this first one looking at first here. So remember, there's your parent function. So now I'm going to come down and turn that dude on. Let's take a look at that. See, there's the bounce, and then there's the through, the red one. Let's come back over here, and let's turn this next one on. See, I just gone over to the y equals, hit enter, and now when I hit graph, you can see it too. And see, look, it went through -2, through 0, and +2, just like it says right there. And so, and you can also see the number of turns. Okay. And then lastly here, grab this guy and just slide it way over there. Okay. So this has no, it talks about the global max and the local max, global min and local min. Well, the parent function has on the cubic has no turns, right? It just has a swerve. So it has no max and mins at all because you got to have a turning point for that. Whereas these guys, there is a local maximum and local minimum for each one of those. Okay. So that's all good there. So take a minute to look at that a little bit more later. All right. So okay, now to the fourth power. It's a very similar thing. See if I can't speed up this process a little bit. So distinct, there's one here, two distinct factors, three distinct factors, and 1, 2, 3, 4. See, I'm hiding the fourth one there. So there's 4 distinct factors there. What are the x-intercepts? Well, that would be 0, 0, and +2. Again, that's what would make it 0. 0 to -2, 0 to -2, and -3. And that's what that says right there. And you can double check that. Again, this is where it's going to cross the x-axis. And it's also the numbers you can plug in to make the thing equal 0. So the same thing. Now it's looking for tangency, okay, or bounces, where it touches or crosses. Okay. Well, see here, this is x to the fourth. It says tangent. So remember, what kind of words did we use for tangent? We used the word bounce, didn't we? We used the word bounce. Tangent's the official math term. That's fine. And then x to the third, it says crosses at both ones. But guess what? What's going to happen here? That is going to be a swerve. It's not only going to cross, but it's also going to be a swerve at the 0. Okay. Then this guy here, what's going to happen? It says tangent. Again, that's a bounce. And then crosses at these other two. Since those are x to the first power, it's going to be straight crosses. And all these are going to be just straight up crossing the way. Okay. So how many turning points? Remember, it's always got to be at least one less. Okay. And we can look at these graphs and we see that that happens there. That's not as big of an issue for the deal. And then we talk about global max and mins and such as that. So let's take a second and look at those graphs. So let's go back over here, and we'll turn that off, turn that off, turn that off, turn that on. Let's go look at the graph. This goes so fast on the computer. And so you see there's the parent function. Okay. Here's our first one. And we said that's going to have a swerve and a through, right? And a swerve and a through. So there, see, there's the swerve at 0 and then a through at the 2. Okay. And what do we notice? This is a absolute minimum. And since this is a swerve, it's neither, there is no maximum relative or not. Okay. And then we're going to go back over here. And, okay. And this square, that's going to be another bounce and a through and a through. Okay. And so that's going to cause what? 3 turns this time. And this is 2 turns. Interesting how that works, huh? So there's your through. There's the bounce at 0, like we talked about, the x squared, and then through here. And then one more, the last one, see what that looks like as well. See, the higher the exponent, these polynomials get very interesting graphs. Very, very interesting looking graphs. And then there's craziness there. But again, we have a through, a through, a through, and a through. And you notice that all of them end going up, don't they? All of them end going up because why? These are all positives in front, right? So it's an even degree. So it means it has to be both up or both down. And since it's positive in front, they're both up. Okay. So, all right. So these are some attributes that we've talked about. We've talked about all these different things, these turning points, the degree, and all these things you can know. There's a lot of stuff going on here. Okay. And then we've studied the cubic and the quartic, just get an idea of some more details about them. So let's do 3 examples. We're almost at the end. I'm going to do 3 examples of where all this stuff pays off. Okay. So the first thing we're going to figure out here is what is the degree? Okay, well, we did one earlier like this, and we said x times x times x will eventually be x to the third. So the degree is a 3. Okay, now that's important because it's odd, which means what? You're going to have one up and one down, right? And so since it's odd and it's positive in front, that means it's going to kind of go like that, right? So what's going to happen here is it's going to be kind of like that. So it's going to kind of do something in the middle, then go up like that. Okay, so that's the first thing we need to figure out is what our end behaviors are going to do. What's going to happen at the ends. Next thing is what are our zeros. Now you could put this first or second, second and first, that doesn't matter. But these are the 2 things we got to do before we go any further is get our end behaviors and our x-intercepts. So we got 0, -2, and +3. Because those are what would make those 0, the x-intercepts. So let me transfer this information over here. Let me put this down arrow over here. As soon as we get this circle, not stopping going around. So we got a down arrow there and up arrow here. So all this stuff is pretty straightforward. Okay, we got a third degree, so we got to have an up and down, and it's got to go uphill. We know it's going to go through those points. Okay, last thing before we go any further, we need to check. When it goes through these points, is it going to go through? Is it going to swerve? Or is it going to bounce? Okay, well, all of these are x to the first. So these are real simple start off. They're all going to go straight through. But this is what I always got to be thinking. So let me go. So the red is what's pretty straightforward, got to happen. And now I just got to play connect the dot. Okay, so here we go. I'm going to start over here. So, and then I'm moving towards this first dot. Now think, do I go through, swerve, or bounce? And this is a through, right? So I'm going to go through. Here I go, went through it. Now I got to go through another point. Where is it? Oh, there it is down there. So where do I turn? Since we're sketching, don't care. Anywhere you want to. You can go way up or just a little bit up or just medium. It doesn't matter, okay, for our sketch purposes. Okay, we're going to go through here again because all these are to the first power. Looking for my next dot. Where is it? Oh, it's over there. So I'm turning around, heading back towards that next dot. And again, this is a through, not a swerve or a bounce. Can go straight through that intercept. And then, oh, looky there. Finished my sketch. No big deal. Okay. So all of these things that we've talked about are coming together so that we can make this happen. So let's look at a couple more examples. Okay. Now, I know I've thrown a whole lot at you here, but hopefully a bunch of it was review just with some new terms. Okay, let's look at this guy. Again, first thing I want to do is say, what is my degree? Well, my degree is a 4 because it's 1, 2, 3, 4. So if I multiply that out, I get x to the 4th eventually. Degree is a 4, okay? Oh, and check this out. What's that negative doing here? So because of the negative, and so we know for degree 4 it's going to be both up or both down. So is it going to be both up or down? Well, this negative tells me that they're going to be both down, right? So this is a down. Reminds me down. So it's going to be, I mean, I don't know what's going to happen all here, whatever, right? But it's going to be both down, okay? So then I got, so my x-intercepts. So we got 1 at 4. All right. Positive 1. Okay, that's positive 1 plus minus 1 will be 0. Then negative 1, and then negative 2. Okay, those are my zeros, my x-intercepts. Okay, so we don't do negative 4. We're plugging in. What can we plug in to make it equal to 0? Because that's what the y equals on the axis. Okay, so we got our x-intercepts, and let's transfer our end behavior. That's what that's called, our end behavior. Okay, these are the things that we know for sure that aren't really hard to figure out. Okay, if it's fourth degree, both up or down, it's negative, so both down. X-intercepts. Okay, now do we have any squares or cubes? Okay, no squares or cubes, so everything again is going to be straight through, no swerving, no bouncing. Okay, so we're still just doing real basic. So here we go. We're going to start. Let's go connect the dots. Okay, there's our first dot. Go through it. Where's our next one? Oh, it's down there. So we got to turn around and go back down there. Going to go through it again. No bouncing in this case. Where's my next dot? Oh, yeah, there it is over there. So I got to turn around, go see it. There it is. So again, I'm going through because there aren't any squares or cubes. Going through. Okay, this is nice. Where's my next one? Oh, it's over there. I'm looking for my next place to go. And again, there's no bounce or swerve, so we're going straight through. And look, we're going straight to that other arrow. Okay, what happens if you don't land like this? Well, a couple of things have happened. Either you put your arrows in the wrong place, or you put your intercepts in the wrong place. But oftentimes, if you're getting good at that, you bounced when you shouldn't have bounced, or you went through when you should have bounced. That's usually where that's going to be a mistake. And practice will help that. So let's do one more practice problem. Okay. So here we go. Okay, now what kind of degree is this? Okay, the degree of this guy, well, since it's going to be a 3, because x squared times x is going to be would be x to the third. So the degree, okay, that's 3. All right, and then what's going on next? Well, that negative in front, what's that going to do? So is it because the negative front is going to be downhill, right? So this is not just down, it's downhill. Okay, so it means it's going to kind of look like this. Some stuff in the middle, whatever, right? Something like that. So now let's go to our x-intercepts, which are going to be 0, so x squared, and then positive 4. Okay, now bring over our arrows, our end behavior, what that's called. Now, before we get started, what I like to do is go double check. Ooh, I see a square. So what's a square going to do? It's going to be tangent or a bounce. So I'm going to highlight this little dude right here so that when I get close to that thing, I know I need to bounce. Okay. If you're just using a pencil, you might do a light circle. You don't have to, but it sure does help us when we're drawing our thing. And then this one's going to be a straight through. So, okay, let's go back to change my color. So let's start from the left. So I'm heading towards my next point. I see that it's going to be a bounce. So I'm going to go touch it and bounce off. Okay, where's my next dot? Oh, there it is, heading towards my next dot. And as I'm approaching it, I ask myself a question. Is this a through, a swerve, or a bounce? And this is going to be a straight through because it's x to the first. And there we go. We landed. Easy enough. So it's downhill because we got a negative in front. Okay, we got 2 turns, and we got a tangent or a bounce, and at these 2 points, we did good. Okay, I know that's a whole lot again, guys, as we've been talking about this idea of graphing polynomial functions, how to sketch the graph using in intercept form, using all these characteristics, these attributes of polynomials. But you can get some more practice at this, and you'll be surprised how easy this is going to be, as long as you just got to keep all the pieces together. Okay, hope that is helpful. Talk to you later.